Alright, so chapter 9, we're going to be talking about imaginary and complex numbers. And for the first section, we're just going to deal with pure imaginary numbers. So what is an imaginary number? So if we started off with the equation x squared plus 1 is equal to 0, and we tried to solve this for x, we go through the process of moving the 1 to the other side, and now we can take the square root of both sides, and you get x equals plus or minus the square root of -1. So when you do that, you're looking at this and trying to figure out what exactly is the square root of -1. Well, if you go back to this equation or this step prior, you're trying to find the value of x that when you multiply it by itself, it gives you a -1. Well, if you are only dealing with real numbers, there is nothing that would satisfy. But when they created the imaginary numbers, just so that they could solve this particular problem, they defined I squared to equal -1. So this is going to solve their problem. So if we go back into this equation and we say, hey, by the way, I squared is going to equal -1, I can replace this right here with I squared. And then if I take the square root of something squared, that means that my solution, x, is going to be plus or minus I. So I, the imaginary number, you can either think of I as being the square root of -1, or if you want to think about I squared is actually equal to -1. And in fact, both ways of thinking about your imaginary numbers is going to be useful in different situations. So don't forget one or only think about one as opposed to the other. So what that means is anytime we have the square root of a negative number, whatever that number may be, we can simplify it by separating this out as the square root of -1 times a, and then the square root of -1 is equal to I. So we can just, if you want to think about it, anytime you see a negative, that just means there's an I in front of the radical, and then you can simplify the square root of a as you would normally have done before, because a is a real number. Or the square root of a is going to be a real number, sorry. Okay, so what we're going to do is we're going to call these pure imaginary numbers. And a pure imaginary number is going to be written as a product of a real number and I. So for example, 2I would be a pure imaginary number. And that's called the I form of the imaginary number, as opposed to having it as a radical. Because technically, the square root of a negative number is imaginary. It's just not in the I form where you've pulled the negative out and turned it into the I. Okay, let's look at simplifying some problems. Here's some examples. So we go up here to the first one, the square root of -5. So if you recall, all we have to do is pull out this negative sign and turn it into an I. So we get I root 5. The next one, that negative sign in here is going to turn into an I, but then we can take the square root of 25 and get 5. So our answer is 5I. And you may have noticed that over here, the I is in front of the radical, and over here the I is after the number 5. And that's simply because you all have messy handwriting, and if you put the I on the other side, I don't know if that I is supposed to be under the radical sign or not. So my rule is that I would like you to put the I in front of the radical if there's ever a radical associated with it. Okay, now when you go to add or subtract imaginary numbers, and they're in the pure imaginary form, the I form here, you can just, it's like combining like terms. So 4I plus 6I, you can imagine, would be 10I, which seems very natural. If you are going to multiply these two things together, the first thing you're going to do is you're going to put this in the I form. So the square root of -16 is going to be 4I. So -5I times 4I, we end up getting a -20I squared. And then you can imagine this I squared, if you recall, it's defined as being equal to -1. So I squared turns into the -1 here. We get -20 times -1, which gives us an answer of positive 20. Okay? Over here, when we go to rationalize the denominator, before we rationalize, we are going to convert this into the I form and simplify as much as possible. So converting this into the I form, since this is a 4 times 3, I can actually pull out the -4 and turn it into the 2I. I'm left with just the radical 3. Now, to rationalize, you are going to rationalize the I as well as a radical. We do not like to have I in the denominator, just like we do not like to have radicals in our denominator. So that means we're going to multiply the top and bottom by I root 3. And when you multiply in the top, you get 3I root 3. In the bottom, you can imagine this I times that I, we're going to get an I squared. Root 3 times root 3 is just going to be 3. And so this 3 and that 3 will cancel. I don't want you to look at I and I squared and cancel that, because then you're back at the beginning where you have an I in the denominator. So instead, convert the I squared into a negative. That's where this negative comes from. And then the 2 that's left over after you've canceled the 3's. So this would be a negative I root 3 over 2. All right, so there's some simplifying of radicals with negatives under it, so all these imaginary numbers, how you would deal with that. There's one last thing that we need to talk about, and that is if you take I and you raise it to some power, whatever that power might be, how can you simplify it rather quickly? So we're going to go through, take a look at this pattern. If we start off with I is obviously going to equal I. But then as we go along increasing our power by 1 each time, we know that I squared is equal to negative 1. And that means that I cubed is the same as I squared times I. So it's like these two things multiplied together, that's going to give me a negative I. And then I to the 4th is the same as thinking of I squared squared. So negative 1 squared is a positive 1. All right, well, let's take a look at the next 4. So I to the 5th through I to the 8th. So I to the 5th, you can imagine, is 1 times I, because it's I to the 4th times I. So it's the same thing that you started off here. Okay, you get the I. And then I to the 6th, you can see how it's the negative 1, because now you're doing I times I to the 5th. And so on and so forth. So if you notice, the pattern repeats itself. Okay, so what's interesting is that anytime I is raised to a power that is a multiple of 4, your answer is always going to be 1. So, keeping that in mind, all we have to do is take a look at our exponents and pull out the largest multiple of 4, and then figure out what the remainder would be. So, if you think about it, if you take your exponent and you divide by 4, if it's a multiple of 4, you're going to get you're not going to have a decimal left over. You're just going to have something like 6 or 8 or 12. But if it's not a multiple of 4, you're going to have some decimal like 0.25 or 0.5 or 0.75. Well, if you think about it, 0.25, that's this scenario right here, and you're going to get 1, or you're going to get I. If you get 0.5, that's this scenario where you get negative 1. If you get 0.75, that's this scenario where you get negative I. And if you get 0.00, that means it was a perfect multiple of 4, and you just get 1. And now think about these numbers in relation to these exponents being a fraction of 4. So look at this. This is 0.25 is 1/4, 0.5 is 2/4, this is 3/4 for 0.75, and 4/4 for 0.00. So there's the 1, 2, 3, and 4 that you see here is the exponent of 1, 2, 3, and 4. Isn't that cool? Okay, so what that means is that when you take something, I know 26 is not that big of an exponent, and you could actually write this as I to the 24th times I squared. Well, here's your perfect multiple of 4. It's going to give you 1, so the remainder that you had left over was I squared. So that's negative 1, so this answer would be negative 1. But if you're doing this on the calculator and you want to look at the decimals here, 26 divided by 4 is 6.5. So if you strip off the 6, because the 6 is just going to give us that 1, since that was the multiple of 4, it's the 0.5 that we're looking for, the remainder that was left over. So 0.5 was the same as 2/4, right? So it's going to be the negative 1 for the answer. So that's how easy it is. You can just look at the decimal here, remember this pattern, and know what the answer will be. So let's try it again, I to the 129th. Now, once again, not that big of a number, but if you have a calculator, it's very easy to do. 129 divided by 4 is 32.25. So 0.25, if you look at that, 0.25 is I. So that means the answer is just I. Take a look at I to the 440. Well, 440 is a perfect multiple of 4, so that's just going to equal 1. It's a neat little trick to remember. Okay, so that does it for our pure imaginary numbers. Hopefully that wasn't too painful for you guys. See you later.